Hello, everyone. I'm Can, and today we'll be talking about a different architectural approach to Xamarin. Generally, as you know, Xamarin applications, we generally use MVVM pattern, like to implement a loosely coupled architecture. However, I see a great benefit using Flux Architecture as well as the MVVM architecture. So I would like to share it with you today. Before we start, let's loosen up with a video that cracks me up every time I see it. This is basically bug fixing in enterprise applications. You fix one thing, another thing breaks, like if the system is not properly set up. In the end, you end up doing something completely different from what you start with. Like you try to fix everything on the way until you actually come to the final piece of the puzzle to get it done. However, another obstacle comes on your way, and you end up with this, basically. So, and this is a true story. It keeps on happening everywhere. Like you change the data model, you change the SQL access layer to fix something, you end up breaking something on the UI layer, basically. This generally happens with long-running enterprise applications. However, you can actually have similar experiences with Xamarin applications as well, like mobile applications, let's call them. So a couple of computer science terms before we get into the topic. Let's take a look. The most related term to the video that we saw is action at a distance. Basically, you do something that affects something completely other part of the system. And this is like one of the worst anti-patterns that you can have, and one of the biggest causes of bugs in enterprise applications. You fix something, you break something else. Second one is side effects. It's not necessarily a bad, let's say, attribute in an application, because we use side effects every day in developing mobile applications. Well, we actually depend on the side effects, essentially, like when we are actually doing some kind of imperative programming. However, if you want to simplify the complexity of your application, if you want to create a more robust application where the formal verification is just enough to verify the feature set that you are developing, you need to get closer to referential transparency, basically pure functions. What pure functions mean is that changing the pure function with another function or the value of the function should not affect the behavior of the application, basically. So we are talking about almost atomic functions. Okay, after the intro with some computer science terms, let's have a look at different architecture sets that we use in mobile development. First one, first and most popular one, MVC. Basically, MVC is used in web applications, in mobile applications, especially if there are any iOS developers among us. Are there any iOS developers? Cool, that's nice. Well, basically, early examples of MVC was actually introduced in Smalltalk. That is basically the basis, let's call it, for Objective-C. Objective-C heavily inherits from Smalltalk. And derivatives of MVC, like let's say evolution of MVC, includes MVA, like the adapter pattern. MVP, that makes the basis for Android applications. And finally, MVVM, that we got introduced by Presentation Foundation, and finally, mobile applications. And of course, you are all familiar with the MVC implementation in web applications, especially with MVC.NET. I mean, there are any web developers. So in this pattern, in the classic approach, we have the user interacting with the view, view manipulating the model, model manipulating the view, basically. So it's kind of like a cyclic implementation. However, this is not possible, basically. Like, at least when you're developing iOS applications or Android applications, this generally deviates from this. Like, the implementation deviates from the actual definition for MVC. What we do is we basically create 3 separate structures. We have the model, we have the view, and we have the controller. Controller, it controls everything, basically. In this architectural model, controller is the star of the show, to say, because it controls the view, it controls the model, and everything goes through the controller. So any user action from the view is actually delegated to the controller. Controller does something with the input, like let it be an action, like a click action, let it be an input parameter or something. It actually updates the data model. Once the data model is updated, it notifies the changes back to the controller, and controller is responsible to modify the view so it reflects the latest data, basically. As you can see, it a little differs from the classic definition of MVC. So this kind of goes to the mediator pattern, essentially. However, the strong coupling between the controller and view actually pushed people to look for some other architecture that can provide a more loosely coupled business logic with a separate view implementation. And this finally came when the Microsoft introduced Windows Presentation Foundation. With the introduction of Windows Presentation Foundation, the MVVM pattern was put forward, because one of the biggest benefits of Windows Presentation Foundation was the data binding concept. So we don't need to actually anymore give references to the view elements in a mobile application or desktop application, as for that matter. We just need to create bindings, meaning loosely coupled interaction items, outlets, between the view and view model. And this synchronization is actually handled by the framework itself, basically. So, in other words, controller is not anymore the star of the show. Controller, here, view model, is just a delegate between the view and the model itself, basically. And again, like the MVVM pattern is borrowed in SPA, single-page applications. Like if there are any Angular developers, are mostly like they should be mostly familiar with the bindings and and data flow. So we said this is the MVC pattern, and when you are actually using MVVM, this MVC block, architectural block, actually can be moved to the view side. So we actually create a view controller kind of thing. That is, responsibility is to display the items and keep the bindings in sync, basically, with the view model side. On top of that, from the separated view, now we have the view model and the model. It all looks the same. I mean, there is no difference, but so in this pattern, we can say that the view, like some argues that the view owns the view model. You can argue that, but still, because only the view has to know what's in the view model. View model doesn't care if there is anything in the view that correlates to the data that it's providing. You can essentially switch the view model to the view, and view model doesn't care. Only the view has to know the data structure in the binding context, basically. And the connection between the view model and the view is done through the binding. And view model is responsible for updating the model and getting the notifications and pushing it back to the view. So we still, on the left-hand side, we still have the coupling between the view model and the model. And this is the part where it gets complicated, because we have a two-way data flow, bidirectional data flow. user input goes through the view model, and data model changes goes through the view model. So the data is flowing in both directions asynchronously. And this actually creates complexities in the view model level, which makes it harder to implement unit tests, harder to verify the structure, harder to avoid any bugs that are happening because of at-a-distance errors, basically. So problems with MVC and MVVM. As we said already, MVC has a strongly coupled model and UI to the controller. And data flow is, unlike the original design, is two-way. And on MVVM, we decrease the coupling between the view and view model. However, we still have a complex data flow. So in some cases, like there might occur such scenarios where the data update was successful, but the view actually shows an error message together with the updated data. This really happens like quite often in modern mobile applications, because at some point the predictability of the view model gets out of hand, basically, because there is so much data flowing in and flowing out of the data source. So, what to do? And in recent years, Facebook, that is a really data-driven structure, data-driven UI, introduced a Flux concept, architectural concept. In the Flux architectural concept, it is basically designed for data-driven user interfaces. It focuses on separation of concerns, but most importantly, it is targeting unidirectional data. User input goes to the data source, it emits the changes, it comes back to the view model. So view model is not responsible anymore to actually execute any business logic that is going down to the data source. View model is just responsible for retrieving the updated data, pushing it to the view. So it's just like one-way data. So it, in other words, it's similar to the original MVC design. In this design pattern, when it's applied to Xamarin, we have a couple of additional layers. So view, we have it from the previous implementation, from the MVVM structure. It's a loosely bound VM data, like it's loosely bound to the VM data and comments. We have the view model that is using the stores and actions to actually deal with the data that the application is handling right now. And finally, we have store, dispatcher, and action. Here, the important part is store and action are the separation of the user input and the incoming data. So we are actually separating the application state from the user input. In other words, we are just changing the direction of the data flow. And dispatcher is just there to handle the data flow between the view model and the store itself, basically. So going back to our triangular architectural diagram, for the Flux in architecture, we remove the interaction between the model and the view model. Instead, what we put is data store and action. So data store is basically just a section of the data that your application generally handles. So if, for example, you are dealing with a service implementation, you have like a whole REST API, how is it called, facade setup, and you are dealing with like a huge amount of data. So in this case, data store would be just a chunk of data that is specifically designed for the current view or associated views. So for example, if you have like a whole personnel management system, this data store can be just a user store, basically, like dealing with the current user or the associated users. And actions is basically the representation of the comments on the view model side. So action, you can actually compare it to the observer pattern. like the event handlers and event arguments, etc. Action is just a definition, static definition of an action that the user took. So if the user took, like clicking on a button, that should represent something in the application data model. If the user said, like, I want to change the first name of my personal details, it's actually an event updating the profile information with the parameter for the first name. So action is just a representation of the action the user took. And finally, we have the dispatcher. Dispatcher is basically just conceptually there. You don't actually need to implement a dispatcher per se, in Xamarin applications at least, because you already have the tool embedded into the framework. Can anyone tell me what is the dispatcher in Xamarin? Xamarin.Forms. Okay. In Xamarin.Forms, there is a messenger interface. Basically, this is the event aggregation module where you create a sub-pub architecture. So you actually can publish messages, and multiple modules can actually subscribe to the messenger interface. So with this information, you can actually dispatch the actions that the user took to different data stores. So think about it. Let's say you have two types of data in your mobile application. One is coming from the service side. One is stored in your local storage. Let it be like a flat file information, like a JSON file, JSON cache or something, or let it be a SQLite implementation, like really structured data. You still have two sources of data. How can we actually control the data flow in this case? So one thing you can do is the user dispatches the profile update. You propagate it to the local data store. You propagate it to the remote data store. Or another approach would be you can actually only propagate it to the data store on the remote server. Once it's successfully finished, you can throw another action to the dispatcher, which will update the local data store. And finally, at the end of this action, we can actually push it to the view model, and the view is updated, basically. So you can actually, at any point, control the flow of the data. And that is the whole beauty of Flux implementation in Xamarin, basically. Another thing, as I said, that Flux architecture brings in, like the added benefit, is the formal verification process. So the metric that defines the robustness or maintainability of an application, one of them at least, is the code coverage. So you write unit tests, and you actually get a value describing how much of the code is actually covered by unit tests. So if the view model complexity gets out of hand, as I said, like there are multiple data sources, data is flowing both directions, and etc., you cannot really take a snapshot of the view model and test it out, because there are lots of multiple interfaces involved in the implementation. So this actually, instead of writing 2 unit tests for the view model to cover like the code, you would need to write 10 unit tests to cover different cases, basically. Write different theories, different fixtures, and etc. to be able to cover all the cases that the view model can execute. However, if you, like, since we changed the direction of the data and delegated the actions that are executed on the data store, now the implementation, the view model verification process is much easier. Basically, we just mock the data store and treat it as a finite automaton, because you can actually predict exactly what is going to happen with the input of the data from the user, basically. So it's basically simplifying the view model side. And data store, similarly, since data store is handling only one type of action, one type of event at a time, you can actually apply the same logic and create these finite state machines that can be easily tested with less unit tests, less test cases to cover, basically. And of course, unidirectional data flow obviously decreases the unexpected side effects. by unexpected side effects, I'm still referring to the first video that we actually saw. Like, in other words, like, no matter how much you cover the unit test cases, if there is no referential transparency in your modules, you might actually get bugs like that is popping up only on edge cases, edge scenarios. So we can take it one step further. This implementation, we are still not dealing with immutable data types. Basically, immutable means kind of like read-only implementation, and that we cannot really change the state of the data. Let's call it that way. And this is really problematic, especially if you are dealing with .NET. And even some argues, like, even you can say that string is not immutable. So it's really hard to create and maintain an immutable state. Basically, this is just another, let's say, attempt to decrease the complexity of the view model. So what we are after is, when I look at the view model at a certain time of execution, I need to know exactly which objects are in that view model, so that I can predict the outcome, so that I can avoid any unexpected results, basically. So the Redux framework actually introduces the concept of reducers. It's kind of like a composite implementation, where the reducer is actually the business logic, the implementation that is going to deal with the actions triggered by dispatcher on the target data store. So imagine you have a list view. You have a bunch of items in the list view, like displayed, that are loaded from the service. And you want to implement a quick filter. Like, I just want to type in like 3-4 characters, and it's just going to filter out the list view. So in this case, reducer can be, doesn't necessarily need to be, a filter action on the list view item source, whatever the source is, basically. You can actually pass the property that will go through the list, filter them out according to certain attribute, and return only a subset of the list. So the incoming list from the data source and the outgoing list are completely different lists, at least talking about the reference objects and the immutability. And once the user removes the query from the search filter, it returns just another list. So the two view states are completely different. We are not dealing with observable collections anymore. We can be dealing with observables, basically, when we go to the reactive implementation. And basically, that's like an extensibility point. If we go further, to recap basically what we currently, up until now, discussed, we are after, with this Flux implementation, decrease side effects. Basically, we want to know when we change something, what it is affecting, so we don't go looking around the house to fix different things. Decrease, as means of decreasing side effects, decrease the risk of action at distance bugs. These are the unexpected outcomes that we talked about. And finally, and I think most importantly, decrease the complexity on the view models. Like, just a personal example. Once, like, since we are dealing with lots of data entries, data flow, data inputs, and etc., at some point it becomes such that when you change a property, you have to fire on property change on like 5-6 different properties, just so the view updates, basically. And that actually is a really big sign of the complexity that you are dealing with in the view model side. And finally, like, of course, using the first 3 items in the list, increase testability. Less complexity, less unit tests, more code coverage, less bugs, basically. So that's the bottom line, and just an intro to Flux architecture in Xamarin, basically. If you have questions, I suggest that you can just find me on after the stage, just not to keep you guys waiting, because we are, I think, already about time. So thank you. Thank you, everyone.